Integration 2, example 12. This is a special example that you should learn. It does come up quite regularly on the exam. I know I'm famous for saying that and then things don't come up, but hopefully this time it will do. At first glance, this doesn't look like an integral you would do by integration by parts. Like I said in the last example, it's for integration of product of two functions. Now this is not a product of two functions, but we can write it as a product. And that's the little trick that you need to remember, inserting that 1 times log x. Now, if we set it out as usual, we've got to call one of these two things u, and we've got to call the other one dv by dx. Now, it's tempting at first to say u is 1, because if we put dv by dx equal to 1, it will get more complicated when we integrate it. And I said in the last example, we generally want things not to get more complicated, we want them to get less complicated. However, I can't put log x here because the next step would be to integrate log x, and that's the whole point of this question. We don't know how to integrate log x. However, we do know how to differentiate log x. So I'm putting them the opposite way around to the way that you would normally think. So if I differentiate log x, we get 1 over x. And if I integrate 1, I get x. So it's not that complicated. So the integral of log x dx therefore becomes, let's have a look, it's u times v, so leading diagonal, u times v, so that's x log x. Try and avoid writing log x times x, because that looks like you're writing log of x squared, which we're not. So try and put the x at the front when you're doing something like that. And then minus the integral of v times du by dx. Now if you're setting it out the same way as me, that's the bottom two. V times du by dx, so it's x times 1 over x dx. Okay, so let's see what we've got there. X times 1 over x is just 1. So we're integrating 1 with respect to x. And so the answer is x log x minus x.